Another SD Times live webinar. I'm Dave Rubenstein, editor-in-chief of SD Times, and today we'll be discussing the risks lurking in AI-generated code. As we've been writing in SD Times, an important issue around using AI to write code is trust, as in, will the code be reliable and secure? Will it violate licenses or compliance issues? Today's webinar will break down some real-world examples of how AI-generated code can introduce security flaws and reduce overall code quality. But before we get started, I have a couple of quick announcements. First, today's session will be followed by a live Q&A, and you can ask a question at any time during the presentation by entering it into the chat on the right side of the screen. Secondly, this webinar is being recorded and will be available for viewing on sdtimes.com under the SD Times Live dropdown. So to get us started, I'd like to bring in Jerome Robert. He's the CEO at Symbiotic Security, and Laurent P., the CEO of PacMind, which offers a solution to fill critical gaps in AI-augmented software development. And now to kick things off, here's Jerome.
Thanks, Dave. Nice to meet you, everyone. Thank you for joining. Maybe a quick word of introduction. So I'm Jerome. I'm the CEO and co-founder of Symbiotic that you can see on the bottom left corner of that slide. I've been doing cybersecurity for a little more than 20 years now. That doesn't make me young, but it's what it is. And I'm today joined by Laurent, who's going to introduce himself.
Hi, folks. Hello, everyone. Really excited to be here. So yeah, I'm Laurent, CEO of PacMind. Like Jerome, we discovered we have many similarities. I spent the last 20 years focused on code quality. I'm serial entrepreneur. And yeah, I've worked on TDD, BDD, and every aspect of software quality you can think of.
Thanks. So the topic that's uniting us today is like, should we basically trust AI? What are exactly the risks that we see behind it? And what can we do about it if there's any of those? So very quickly, the agenda for today will be a very quick introduction about what do we mean by AI-driven code generation today? What's available? How important it is to developers, and what is good and what's not about it. We'll jump then through what we think really matters, what the data shows about it, and then we'll go to actionable strategies that you can use to, it's not about, but let's avoid AI. It's really about how can we use it in a way that is beneficial for from every angle, right? Security, productivity, quality of code, stability, etc. So without further ado, just one thing very quickly about the level of adoption of AI, right? Well, I'm not going to read through that whole slide, but a summary is nearly 76% of respondents on a fairly large sample, by the way, are using AI for coding somehow, right? It's I think it's amazing to see the level of adoption in AI considering the short amount of time it's been available. And that also says at 76% for sure, it is a core practice now for developers. It is not something it's not an edge case. It's not something that the most early adopters use. It's really something that is mainstream. And the level, again, of the speed of adoption is pretty amazing, notably considering all the question marks we can have around it. And so I'm tempted to ask you, maybe first question for you guys is, well, considering most likely a lot of you are using AI, what's your level of trust? We're going to have a poll set up, I think. I can't see I don't have video feedback, so let me know if we have the poll set up.
Yeah, the poll is just starting.
It's live? Cool, thank you, Laurent.
And obviously, if you have no access to AI, just don't answer. But if you have access to AI and don't use it because you don't trust it, then feel free to answer.
Then yeah, That's in and of itself.
So let's see, Jerome, if our audience trusts AI a great deal, a lot, somewhat, or a little.
Yeah, tell me, because again, I don't have the feedback.
Yeah, it's just coming up. So far, I would say we start to see emerging some patterns. So I would say by far almost 50% people trust AI somewhat, and then it's almost a bell curve, 16% a lot. We have to talk, folks, for the ones that said a lot, and 26% a little, and 11% not at all. So that's interesting. Thank you for taking this poll, and now we'll see how you compare to the industry.
Yeah, that's from what I hear, it's actually pretty comparable to the actual measure, which is interesting. In all honesty, when we were preparing with Laurent, we thought like the people coming to such a webinar, they're going to be maybe like a little more skeptical than the rest. No, we are actually right into the pattern that we see on the general population, which is great. What can we say out of this? I think one thing that is interesting, looking at that picture first and linking that to the fact that we have nearly 76% of respondents using AI, right? It means that a bunch of people who are in the somewhat zone are still using AI, which means a lot of things, right? Like that speaks about the rapid adoption. Like people who are somewhat skeptic about it are still using it because it's so helpful. I think another interpretation might be that people who are somewhat trusting, therefore somewhat distrusting AI, feel that they have enough competency themselves to be able to judge whether what the AI creates is good or not, which is an interesting finding, because we'll see later that skills are very important. In the overall picture, I'd say it's well known that security is still a barrier. Like when people don't trust AI, there are many reasons. Security often comes first or second. The last thing, and I think Laurent, you know more about this, but there's a wide disparity on level of seniority. I'll let you talk about this.
Correct. Yeah, I just wanted to jump in this one, because if we look at let's say the same results by seniority level, that's a very different picture, and we're going to discuss that in depth in the second part, the different behaviors, juniors and seniors, the way they use and leverage AI, it's very, very different. But also when it comes to trust, and that's pretty obvious, seniors tend to be more skeptical, so they will challenge way more the output from AI than a junior person would do. And the reason is, again, pretty obvious. They have they have some strong opinion. They have an idea of what good is. So they know how to challenge AI, which may obviously be slightly more difficult for junior developers. So that's the average, right? That's the average.
So this is somehow a picture of what people think about AI. Like it's what we have seen in our experience is it's somehow rarely rooted in actual science, like the data or anything. It's really about how we perceive individually AI and its the positive impacts it can have and the negative impacts it can have. So we have compiled a few data for you guys so you can see actual science about how good it is, and it is good, and how sometimes bad it can be or ugly it can be, right? So we're going to go through few characteristics, statistics, all of what we are going to show, by the way, when we will share the presentation, is in the last slide as references. You'll see it's mostly research papers. So I think those are data we can trust, right? It's not us, it's really academic research. So let's get started with the good. Obviously, there's a gain in productivity. And I think that is what makes AI so compelling, is we overall can go so much faster in achieving individual goals and individual tasks. What we can see is that is data from Dora, by the way, from Google. 25% more utilization of AI in a group increases, but you could also say like somewhat marginally increases job satisfaction, decreases burnout, which is great. It's really personal. It's really about like your happiness at work. And also it increases the amount of time you spend in flow state. So when you are really, super effective in your tunnel, very focused. So this is more about productivity per se. Surprisingly, again, like those numbers are not huge, right? They are marginally better, but they are not like a game changer. The 26% top on top,
Yeah.
though, definitely.
On this one, Jerome, yeah, the 26% from a manager standpoint is amazing. I can just do the same amount of work with 75% of the team. So that means savings. And we know, obviously, it's not the case. And we could do the whole webinar on what productivity means. And there are so many definitions for these specific webinars. And when we look at the metric that has been being used on the different survey, it means the 26% increase in the number of tasks completed. Right, so that would not be my personal definition of developer productivity. I'm sure it's not necessarily yours. We could debate that, but for this specific topic and the papers that have published data on that, the metric is the number of tasks completed. So it is what it is. At least it's in velocity.
Thank you. What about the bad? First thing, I guess, is from a security standpoint, people should know that GenAIs routinely create vulnerabilities. Like it is not perfect by far. And when I say by far, as you can see, it's about 40% of the code snippets that were analyzed using like a wide range of models and a wide range of training for those models. The average is like 39% of those code snippets having vulnerabilities in them, which is very significant. Again, this is a study it's a statistical study that was made over like more than 1,000 pieces of code, I believe. So it is conclusive, is what I mean, right? So security is definitely one thing that AIs don't get right today. Something that could have been in the ugly section, but that we keep on the bad because such attacks are still unlikely to happen for a while, is poisoning the AI models, right? So the fact that someone could actually prompt against the AI in such a way that it would make the model drift towards providing bad answers to future users of that same model. It is a tangible problem. It is something on which we have proof of concepts. However, the level of efforts that threat actors would have to put to actually achieve this is very high, and they have a tendency of using the path of least resistance. So it is a real problem that everyone should be aware of. However, real-world attacks are yet to be seen. What we can see, though, that is very tangible is the reduction in delivery throughput, right? And so it's kind of counterintuitive when you look at the productivity, which is why Laurent made that point before. But use the 20, and that's the same statistics, by the way. It's 25% more usage of AI creates a 1.5% reduction in throughput and 2.6% frustration, meaning less time actually spent on valuable work. So there's, again, something that is about like your productivity or your throughput, and then your happiness at work, which is how much time you spend on something that you think is valuable. Finally, there's that over-reliance, that temptation of over-relying on AI, not verifying enough, not trying to understand what we are doing, that can have a honestly catastrophic side effect, which is reducing the coding skills. And I don't think we are in a situation where we could say, well, we don't care about coding skills because the AI are doing that and devs need to do something else. No, devs need to understand what the AI is doing, because of the reason you just laid out, right? When an AI creates 40% more vulnerabilities, creates 40% vulnerabilities in the code snippets that it creates, I mean, not being able to understand where and how that AI created something wrong would be a real problem. So that reduction of skills is a very immediate danger, I think. On the ugly side, right? Because this is not marginal. First one, same statistic from Dora: 25% more AI leads to a 7.2% drop in instability, which is, I mean, close to unacceptable, I believe, right? We all strive with our services and SaaS services, we all strive for total uptime, 100% uptime and total stability, and because of the user experience and just because we want to deliver the services we're supposed to. 7.2% is a huge problem. AI propagates wrong patterns. What we mean by that is, unfortunately, and it's particularly true in the realm of code generation, it might be less true in other areas, but there aren't many ways to train an AI at scale on code. You have to provide it with a ton of code. Where do you find that code? Online, GitHub typically. So you scrap such websites, you give a ton of code to that AI, and what happens is the AI has the exact same level of mediocre quality as whatever you've put in, right? So garbage in, garbage out. If you have wrong patterns in whatever you gave for ingestion, well, that AI is going to replicate those wrong patterns, because what the AI is going to create is going to be, again, published online and is going to be used by other AIs or even itself for training. Well, you have like that propagation and compound effect on wrong patterns. We really have science showing how models can drift like this. There's that notion of AIs going mad being an acronym for not being mad, but just being degenerative. And this is a real thing. This is a real pattern that we have to take care of.
And that's interesting, Jean, because I've seen a few teams wanting to that were using AI, hoping that the code base full of tech debt and the legacy would improve. And this is exactly the opposite that happens if you don't steer it intentionally. It will, as you mentioned and described the phenomenon really well, it will just amplify the cursor, GitHub Copilot, just amplify the files and the patterns that it sees.
The issues, yeah, and I think it's a learning for the big AI players out there, and they of course they know that. It's the fact that the quality of the data that they use to train their AI is very important, which is one of the reasons why, from a security standpoint, it's so mediocre. It's because it's pretty hard to find at scale a data set that you can use to teach an AI on security, right? Something that would be, hey, here's a piece of code that is vulnerable, and here's the fix, and that fix has been verified by a human that knows what they're doing, and it's annotated, it's labeled, and everything that you need so that you can give that to an AI for training. That data is not available. The best people do, and it's not good at all, is typically take GitHub, scan that for vulnerabilities, ask the AI to fix those vulnerabilities, and give those results to the training of the AI itself, right? Self-ingesting data, training data leads to that drift that we mentioned, like degeneration, or difficult word for me, sorry, degeneration of the AI model. Lastly, and I find that very, very interesting, almost from a psychological standpoint. There's a very interesting study that dates from, I think it's July or August 24, so it's not long ago, which shows that somehow developers tend to unplug their brain when they're using AI. And so at the end of the day, when you are developing yourself, you create so many, like that many number of bugs, whatever. And if you use an AI, you are going to most likely create more bugs, because you don't account for the bugs that the AI is going to create because you trust it blindly. And so you're going to be a little more careless. You're going to count on the AI for fixing your own stuff, as Laurent just mentioned. And at the end of the day, you just create more bugs than if you were developing without that AI, which is again kind of counterintuitive, but very interesting in terms of just the intent, how we use AI, and being realistic about what it can do and what it cannot do. I think would fix this. I think it speaks of the immaturity overall of the general population about AI. So speaking of, sorry.
I was about to say, in all fairness, we should say that even if we feel like we've lived with ChatGPT forever, now it's still pretty new. So, I mean, as humans, we still need to adapt, and we know we are pretty slow to adapt or to best leverage these tools. And the technology is evolving so quickly that I think we have to be also humble and open, and just say that what we share today is the situation as it is. It was in 2024, it is in 2025. Maybe in 2-3 years from now, it will be it may be a very different. So yeah, let's just keep in mind that it's a domain that is evolving really quickly. Having said that, so thank you, Jérôme, for sharing all these data. We've seen that there can be tremendous value in leveraging AI, a lot of benefits, but it also comes with a lot of downside that we have to be really aware of. So the question is, how do we get the benefits without the downside? And what we're going to discuss now in this section is what we'll see is that skill is the single most critical factor to leverage AI effectively. So let's start by I will start by this number again. So AI boosts developer productivity by 26%. What I want to do now is kind of double click and see how developers, based on their maturity level or seniority level, benefits from this acceleration. And we'll do the same for the different other aspects in terms of quality, and see that different seniority level really drives different outcome. So when we say on average it's 26%, it's very different, the level of acceleration or productivity gain, number of tasks completed. If we look at junior and senior, junior developers report between about 20 to 40% productivity gains. So I complete 20 to 40% more tasks when I use an AI coding assistant, GitHub Copilot, Cursor, or something else, compared to just working with my IDEs without AI. Very different for senior developers, because they report gains between 7% to 16%. So it's very interesting that senior seems to have a lower leverage of AI. So why is that? And we're gonna answer the question in a second. The other things that data and science show us is we create more code faster, right? We could say amazing, but that code has to be reviewed. So that creates a pressure downstream in the development life cycle. So especially in code review, but also CI, the build, so time to build. If it's long and you have more and more build things to test, it will be increasingly complex to manage. What's interesting there is when you look at the difference, and I think someone raised the question before, the difference between a pull request that has been purely written by a human versus a pull request written by AI. Again, data shows, and you have the reference at the end of the slide, that a pull request that has been either fully generated by AI or influenced by AI. So having accepted some code suggestions, autocomplete, the level of rework on this PR is, the range is 20 to 35% more rework than for human generated one. So that means two things. We have a kind of compounding effect here. We have more code to review, and the code that we have to review require more rework, right? So it's fine to say I'm just creating more code faster, but that's not the biggest deal. We have to look at this as a system and look at the full value chain. And what we see here is a lot of issues in code reviews. And if you miss these 20 to 45% of PRs that really needed rework and let them go to CI and production, then that will be problems that will be even more expensive to fix. So it's not the same quality. The other very interesting data point that these studies show is that that will explain the first point, why senior seems to have less leverage in terms of velocity than junior developers. Senior engineers tend to reject code suggestions from AI 3 times more than junior do. So we could say, oh, that's bad news. No, I think it's good news. It's a good use of their knowledge, their critical thinking. As I said earlier, they have a definition of what good is, right? And that's the reason why they can better judge if a suggestion is good or if it's not good. And there is also something that we tend to overlook when it comes to development is the knowledge of the context. So it's not necessarily just the technique. Is it the knowledge of the language, for example? You can know perfectly the language, the syntax, but what matters often at the end of the day is the knowledge of the context. And usually senior developers, they know the domain, they may know the business or even the users and what's important for the project. So context matters a lot. In fact, it's often make a big difference. And technical decisions that you make on a project, for example, in terms of architecture, design, coding guideline, they can vary from one project to the other. I used to have the responsibility at Smartbear of 6 products, exactly same tech stack, right? It was Java backend, React for the front end. So we could say same way to develop. AI can apply the same practices. Well, no, because in some products, with a lot of users, we really cared about the performance. So performance matters. In others, it was more reusability. So what are the trade-offs that we do? What matters in our context? Well, AI doesn't know, right? And that's where typically senior will use their judgment to better accept or reject compared to junior developers. So overall, what it does tell us is skills matter, and AI tend to amplify this knowledge gap between junior and senior. So that's something we have to be really careful about. So the next question that is interesting is, why do junior don't really benefit from AI on the quality standpoint? Well, the answer is a really interesting one, another cognitive bias. So that's called the Dunning-Kruger effect. And that's what explains this paradox with junior developers that go faster in short term, but in fact create more issues at the end. So long-term ROI is pretty negative when they use AI. It's the Dunning-Kruger effect. So this is what is explained in the chart on the left. So you can see on the x-axis the cluster of developers by level of expertise, right? So the less expert juniors on the left and the senior on the right, and then this is how on the y-axis they score level. So how do they perform? What is their score on different coding tasks? So what's interesting is now when we compare this to the perceived ability, and that's what the Dunning-Kruger effect is about. It means that what you can see here is as a junior level, if I don't have much skills, I don't know what I don't know. So I will perceive my ability way higher than what my actual skills are. And it kind of, it's kind of the opposite when you are really senior. You have tons of knowledge, but you also know everything that you don't know. And you will tend to assess your ability lower than your actual skills. And interestingly, AI amplify that cognitive bias, because even if I don't know, I'm almost never stuck. AI always has an answer for me. I don't know if it's good or not, or bad, but it has an answer. And in code, usually it has an answer that seems to work. So juniors basically have a inflated sense of confidence with AI, which increase this Dunning and Kruger effect. And that's why they adopt AI quicker than the usually senior. And they have more productivity gains in the sense that they complete more tasks faster. Is the code right? Good, sustainable? Will we have more rework in the future? The answer is yes, but if we just stop or look at the productivity definition as task completed, check the box. So that's a really
because
one.
Am I right? In most cases, functionally it works, right?
Yes, seems to work on 80% of the cases. Yeah.
Yeah, functionally it works, and then deals in the details.
Yeah, I've used myself, so we can go to the next. Yeah, I've used myself Ripley to create a web app, and honestly, it worked on 80% of the use case. But to get the 20% of the rest working, it's impossible. You just have another bug after another bug. It never converge. So that requires expertise, and that's why senior developers, as I said, are extremely skills is really important. That's why senior developers reject 3 times more suggestions than juniors, because they have this notion of what good is. They have the understanding of the context. They have also a better understanding of the tool itself. AI is a tool. It doesn't have all the knowledge. It doesn't know my context as well as I do. And because AI is a tool, they also looked more critically at the tool, right? It's what are the strengths and the weaknesses. So it's not also applying AI blindly to every single task, to create my test, to create my code, to do everything for me. I will use AI for its sweet spot, where I've seen in the past AI being good at, and I will tend to unplug it for tasks that I've seen it struggling to, so kind of wasting my time. So that's also an important aspect of seniors. And overall, what we can say is definitely senior developers. It shows in the data, and in all the, I would say, different recs I've seen of teams using AI at scale. They can really apply their experience and oversight to make sure that they leverage AI in a way that maybe it seems they get less velocity gain than junior teams, but they don't get velocity at the expense of quality, reliability, and maintainability. So it's really more sustainable. And I think when we look at I mentioned the ratios between 7% to 15%. If you leverage AI the right way, I think this is a closer range. 10% can really accelerate you compared to the 40% marketing ratio that you've probably heard from Microsoft. So we say that skill is absolutely important, and skill is the leverage to better outcome and more sustainable outcome with AI. So I'd say not only skill is the leverage for AI, the better leverage for AI, but it's also the ultimate shift left. So as I said earlier, I'm in the quality space for 20 years now. I've done TDD, BDD, DDD. So shift left is my bread and butter. The ultimate shift left is about upskilling people, right? When you look at the cost of fixing an issue, you know that the longer it takes to detect an issue, for example, in production, the more expensive it will be, exponentially more expensive than addressing
expensive. Sorry, Ron, expensive and frustrating, right? Like having to go back to old code and being told by someone else or something else that what you did is wrong. Like all of that creates so much frustration, which at the end of the day kind of desensitize developers against those issues.
Yeah. And if you do the 5 whys and really look at what's really the root cause, I've done that thousands of times with my teams. It's always end up at some point being about someone not knowing something. It's always at the beginning about a skill. So if you really want efficiency, upskill your people. So that's why I say the ideal scenario to prevent the issue, well, build skills, learn. That's the best thing you can do. The best way to avoid a code is to not write that line of code that is buggy. So you need to upskill people. The next best place to detect an issue, and I know we'll talk about that later, Jérôme, when we'll talk about the solutions or actionable strategies, it's in the IDE, right? Because I can't know everything, so sometimes I do mistakes. Better learn there, have a feedback loop there in the IDE rather than in code review, CI, or production. And even in code review, I would argue there is a huge difference between being notified of an issue in the IDE and code review, because when it's in code review, in most of the teams, there is a few hours between the code commit and the review, if not days. That means as a developer, I work on something else, which means context switching. And we know that context switching is what really kills the developer productivity. So upskilling people, and that's the main message here, not only is the key lever to better leverage AI, and we've seen that by the data, but I would also say it's what makes sense from a financial standpoint, because the more skilled people you have, the less rework you will have to do in the future, and the more savings you will do. So if we say, Jérôme, as an entrepreneur, especially for us, a startup, when we talk to others, everything is AI, right? Oh, you have a problem? Well, let AI do it. So if we say it's all about skills and it's just about upskilling people, then why don't we just ask AI to do it? Well, there is and I had this, someone asked me that question, by the way. So I think when it comes to learning, it's really tricky to just rely 100% on AI. The same way it's really tricky to rely on AI to generate all your code. Learning or upskilling requires intentionality. That means that if you think about the mentor and the mentee, as mentee, I need to be ready. I need to be open to learn, right? As a mentor, I need to know the context. I need to know in which context you operate, what are your strengths, what are your weaknesses, so I can better help you address these gaps. So that mapping of the let's say the skills, that mapping of the context, and I get back to the context again, is something that is very difficult for AI to understand. So AI can definitely be helpful to scale the existing knowledge, but it has to start with the context, and it has to start with the people. There is a very interesting experiment that has been run by MIT, just to mention it briefly. So they have asked 3 teams to solve a problem using Fortran, so a language that is no longer used. There was no much data about that. And for two of the teams were able to use one ChatGPT, the other one LLama, and the third team was not able to use AI, just Google the old way. So interestingly, the folks who completed the task faster were the 2 teams using AI, right? Not a surprise. Google team was the last one. But when it came to a few days later, remembering, oh, by the way, you remember we've asked you to solve this problem. How have you solved it? What have you learned? the first two teams, they haven't learned anything. They were not able to remember the strategies, the algorithm that were used to solve this problem. And the third team that did it manually, that did struggle, was able to. So there is no shortcut to learning. And I really love the quote of this, or the key takeaway of this survey. Working hard and struggling is actually an important way of learning. When you are given an answer, which is basically what you have with AI, you're not struggling and you're not learning. So that's why you can't just rely on AI. It has to be intentional.
And so now that we've said that, right, we say you gotta improve your skills, you gotta help your teams upskill so that they can use AI, so that you guys are safe using AI and you can really take advantage of everything it has to offer. It may feel a little theoretical. So just very quickly, a couple of strategies. We're going to talk more about ourselves, I guess, about how you can do this. Laurent, you want to kick that up?
Yeah. So they are, according to our experience working in this field, shifting left, upskilling people, three, I would say, principles that are really key for strengthening oversight and upskilling people. The first one is that it should be human supervised. Just share this experience about MIT. You can't just let AI do everything for you. You have to be grounded in your context, and understanding the context with all its nuances. Start with the people that work and are in this context. So either it comes to create code or address vulnerabilities, or start with what are the actual problems that you are facing, what are the skills that you have in-house, what's the context, and then you can use AI to leverage that. So first principle, it has to be human supervised.
Just in time is equally important. There's actually a ton of academic studies about the effect of just in time for learning. It's been studied for groups of students in various areas. It's been studied for adults or people working and working on the job. So just in time is really what it means, right? It's you are going to learn better if you're given the information you need at the time when you need it. If you get that information in a classroom and you don't apply it immediately on the job, I mean, it's good, it's one thing, but it's not about practicing, which is what you see on that pyramid on the left, by the way. One of the best ways, really, to learn is by using immediately the information that was given to you in a concrete case that is useful, not just a case study, but actually something that's on your daily life, on your daily work, right? So just in time, giving people the exact amount of information about the exact problem that they need to solve right now is how you achieve actual upskilling. In the flow, I mean, it's more about, it's also about like learning on the job, but it's also in terms of adoption of learning, right? We all love to learn. Do we like interrupting our lives and our professional lives, and therefore, by the way, hurting our velocity as developers so that we can learn? Not really. So learning has to happen where you work. It needs to be as marginal as we can from an interruption perspective, an amount of time spent perspective. So it has to happen in the flow of what you're doing, using your tools, your workflows, and I would even say your habits, right? So this is, I think, the building principles on which we at Symbiotic and Pacman have built our solutions. Maybe Laurent, you want to spend a few words on Pacman?
Yeah, I can say a few words about absolutely about Pacman. So Pacman is what we call the tech lead copilot that enables team to leverage AI more effectively and reliably. We've discussed it, but as AI coding assistant like Copilot and Cursor and others become more standards today, We've seen that engineering teams struggle to align the output of these tools with their own standards, and that causes issues, technical debt. We've shared a lot of data points about this. So PacMind, coming back to the first principle, it has to be grounded in new context. It should be human first, gives tech leads the ability to enforce context-specific best practices, and that across IDs, code reviews, CI pipelines, to make sure that every line of code that is produced, either by developer or by an AI assistant, AI agent, is high quality and aligned with your context. So if you go to the next slide, I will just show you the workflow, how that works. So PacMind is a web app and a set of plugins that you can install in your IDE and CI. And the first thing that is critically important is to get the context. So what is the context you operate in? What are all the trade-offs that you've made? All the technical decisions, right? About architecture, about design, about coding guidelines. So we find this in different ways. They are in different places, wikis, Notion, Confluence, and others. Some people have their architecture decision records there or in Git. When you do in the code reviews also, it's a super valuable source of technical decisions, because when we, for example, add a comment to a pull request that was generated by AI and say, no, it's not this way, we should do it that way for this reason, we can look at the rework, the code change that was accepted, and from this infer technical decisions, the why behind that. So there are many ways to capture the context, and we do that through this integration. And then in the web app, basically, PacMind provides like an inbox, like your traditional inbox, where you received all the meaningful technical decisions that have been found daily or weekly, depending on your cadence. And then what you have to do is just swipe left or right, to take that analogy. So either you say, no, that's not a decision that is critical, I want to enforce, or the opposite, yes, this one is critical, I want to make sure this is part of our standards, this is part of our repository of technical decisions, and I want to make sure it's applied everywhere by developers and also by AI. So once you validate a practice, like a linter on steroids, PacMind will automatically configure this, so you have nothing to do, these technical decisions. And a few seconds later, in the IDE of developers, depending on the repo they work on and the workspace they belong to, but they will see this guidance directly in the IDE. So if they don't follow the rules of the road or the technical decisions in the right context, PacMind will give them some guidance and say, hey, you know what? That's what you should do instead. Obviously, we also give that context to AI agents. So through cursor rules, GitHub Copilot configuration file. So we can provide them the rules of the road for the different repositories, and that increase the likelihood that the output of the AI will be aligned with what you do. But even if it's not the case, because we act as a linter, we'll catch the differences, right? We catch it at the code review level or continuous integration level. So that's basically the workflow. And as we've seen, that's amplify the tech lead, make sure you get the right outcome from AI, and follow the 3 principles that we've shared just before. So that's for PacMind at a glance. And I know, Jérôme, you have a few minutes left to talk about
yeah, let's do this. All right, Symbiotic is focused on cybersecurity, so very close to, I guess, what Laurent presented before about what's the best solution for all of that. It's to upskill people. What's the second best solution is to do detection at the IDE level. Those 2 things are what we're doing. So we're really shift left security. We have an IDE plugin that basically detects vulnerabilities as you are writing those vulnerabilities. It's a tool that's been designed for developers. So if you think about the things that we detect, for example, we don't just say, oh, this is critical, this is average, this is medium, whatever. which is interesting, an interesting metric, but it's mostly interesting for security people, not for developers. What we provide though is something like, hey, you know what? If you don't fix it, this is not going to pass the controls that we have in the CI. So if you don't fix this, then you're going to have to go through the whole rework problem we mentioned. You're going to have the frustration of seeing those alerts coming from security and telling you you've done a bad job. So we're giving them the visibility so that they, continue to enjoy their job. So it's really about detection, very early detection. We provide AI-driven remediation. It is AI-driven. However, our AI is like completely specialized, and it's being controlled to everything, to other models. We are trained specifically on human verified data. The real differentiator at the core of Symbiotic from an AI perspective is the data set that we've accumulated. So detection, real time in the IDE, remediation, real time in the IDE thanks to AI, and upskilling in the IDE as well. So the flow is, you are writing your code, you're creating a vulnerability, we're telling you if it's dire or if it's okay, and we're telling you how not to repeat it. So right there in the IDE, you have a short learning track. It is not a video. It is not like questions, gamified things, etc. It's really how people, like developers, love to learn by themselves. It's a couple of good examples, explanation, bad example, explanation. It's very quick. It takes like maybe 1-2 minute max. And then you can get to the remediation part of the solution. We're seeing a lot of impact with this. We're seeing a ton of what we call avoided issues, meaning issues, vulnerabilities that were created, but that got fixed before it ever got committed. So not even before the CI, but even before the commit. Those are pure ROI. It's from a security standpoint, it's great because it's security issues that don't go into production. But from a developer standpoint, that's less time spent on security. This is really about, I'm able to apply security for marginal effort, marginal amount of time, not hurting my velocity, right? And we can see, like our data shows how people progressively, just by seeing, even if they don't really invest a ton of time, but just by seeing the explanations and the training we have in the IDE when they go grab their remediation piece of code, just by that, we're saying the number of vulnerabilities that they create decrease over time, which is a great indication of, again, upskilling makes sense and makes everyone's life easier.
Cool. So what we've seen is this is the list of references, and the two solutions, Pacmine and Symbiotic Security, enable oversight at scale in the age of AI, right? And applying the same principles, shifting quality left. So we have for you this last slide. We would like to thank you, and we're going to answer the few questions that are still open in the chat. You can see 2 QR codes. So if you want to follow up and continue the conversations with either Jerome or myself on security or on code quality generally, and how it can help, our solution can help upskilling your teams and apply this control and oversight on AI generated code, happy to do it. So you can just scan this QR code and you will have access to our calendar. So now what about we answer the questions? So I can take the first one. If 76% of coders are using AI, what happens? It's the second one, sorry. No, the first one is about the type of model. So are these AI models, is there any AI models that gives better performance than others? Well, I'd say, I don't know for you, Jerome, but what we've seen ourselves and heard from multiple customers is that Claude, which has been really specialized on coding, gives better outcome for everything that is about code. Claude Sonnet.
From a security standpoint, so we have a continuous pipeline benchmarking all those models with different level of trainings, by the way. So we have several times the same model. Claude is good. DeepSeek is better. Interestingly, DeepSeek is better with less amount of training, but most likely more specialized training. So yeah, there are variations. Let me say though that they are not black and white. Like it's not like, okay, I just need to take that model and I'm good to go. No, all of them have the same issues. Just like top of my head, I'd say DeepSeek probably like generate, like if you look at how capable they are in terms of remediating security issue, I think DeepSeek is like 70%, and then you're going to have Llama at like 50 something percent, right? So
okay.
DeepSeek significantly better, both significantly not where we need them to be.
Yeah, for sure. All the shortcomings that we have discussed. That's not a question, but really some, I think that's Ira said this, build skills has always been a good idea, and it's orthogonal to using AI. Yes, so the two are obviously not related. I think the more you want to use AI, the more you should invest in skills. So they are definitely orthogonal, but they should go together in terms of investment. I've also seen, which I found to be pretty clever, a few organizations starting with adoption of AI coding assistant first with senior developers, so they can build confidence, understand the strengths and weaknesses, and then as they've built this control and oversight, deploy it more broadly to the organization, including juniors. So it's orthogonal, but it should you should invest in both at the same time. A question that maybe is for, sorry, David.
Yeah, no, I was just going to apologize for the little glitch that I had there. But it looks like we're really right up against time. So any questions that we didn't get to, we can answer either via email or what have you. Certainly like to thank Jerome and Laurent for an excellent presentation. I can tell by the amount of chatter in the chat that's been going on that this has been an engaged group, and we'd love to see that. Certainly also want to thank Symbiotic Security for sponsoring today's event. Thank them very much. And of course, thanks to all our loyal attendees who came through today to join us. So until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.
Thank you, folks. It was a pleasure. Bye-bye.